Hello everyone and welcome back to What the Heck Math. Today we're going to answer the question, what the heck is the Monty Hall problem? Or I guess, what the heck is the solution to the Monty Hall problem? So just to kind of give you a background about what the Monty Hall problem is, let me lower my brush size. So Monty Hall. So Monty Hall is the name of the original host of this a game show that was on TV a long time ago called Let's Make a Deal, and this problem is based upon that game show. So the Monty Hall problem is set up this way. So you have the contestant has three closed doors in front of them, and they're told that behind one of these doors is a brand new car, sports car, Lamborghini, Ferrari, something like that. Okay, so behind one of these closed doors is a brand new car, and behind the other two doors is something they don't want. And very often in the explanation of the Monty Hall problem, this something they don't want is a goat. Now, unless you like goats, that's a bad thing. Okay, you'd much rather have a sports car than a goat. So the contestant is told to choose one of the doors. Okay, so for example, let's say the contestant chose door number 1. Okay, so this is door number 1. So this is what the contestant chose. Now, hopefully, you know that if one of the doors has a Ferrari, the other two have a goat, the probability that you will choose the door with the car, is 1 out of 3. So you can say that the probability that the door you chose has the car is 1/3. And the probability that the doors you didn't choose has the car behind one of them is 2/3. Okay? So after this choice is made, what ends up happening is that the host reveals or opens one of the other doors. And so after they open one of the other doors, it's revealed that behind the door that they open is one of the goats. So here's a goat. Okay, so they open one of the doors, and there's a goat behind it. After they open that door, they then ask you, or ask the contestant rather, do you want to change your mind? Do you want to instead choose the other door? So the question is, with the Monty Hall problem, should you change your mind? Is it mathematically a better idea to change your mind, or is it better for you to stay where you were? Or does it matter? Okay, is it equal? Now, at first glance, it looks as if, well, you have two doors, the car is behind one of them, and the goat's behind the other, so it's a 50-50 chance. But the actual answer, so 50-50 chance means, okay, well, I might as well just flip a coin. It doesn't matter which one I pick. It's going to be the same probability. But the actual answer is that it is a better idea for you to change your mind and pick door number 3. Okay. Now, the reason that this is the case is highly dependent upon the fact that the host knows where the car is. If the host didn't know where the car was, then yes, it would be 50-50, but it would also be a chance that when he opens a door, he ends up showing you the car behind that door. Okay? But in this case, the host does know where the car is, so because of that, it is better for you to choose door number 3. Now let's explain why that is the case. Give me a little bit more room to write here. Okay. So, as we said before, when you choose a door, it's a 1/3 probability that the car is behind that door, which means that it is a 2/3 probability that it's behind one of the others, or behind one of the doors that you didn't pick. Now, once one of those other doors is open, that 2/3 probability is now concentrated onto one door. It moves over and it's just focusing all on one door. So now it's a 1/3 probability that it's behind the door you chose, and a 2/3 probability behind the one remaining door you didn't choose. So basically that's one of the reasons that's the reason why you should change to the other door. Now let's look at it a different way, because this whole concentration of probability is kind of a strange idea and a little bit hard to understand sometimes. Let's look at it a different way. So let's think about it this way. Okay, so you have door number 1. Let's do this. Door number 1, door number 2, and door number 3. And let's say this is the door that you chose. So let's list all the possibilities of outcomes. Okay, so first possibility, which is the one that you want, would initially at least, is this would be the car, and this would be a goat, and this is a goat. Another possibility is that this is a goat, this is a car, and this is a goat. Another possibility is that this is a goat, this is a goat, and this is a car. Now, these are the only 6 possibilities as far as how you can arrange the car and the goat. Okay, and this is based off of the idea of 3 factorial. Okay, now if you chose number 1 and he reveals a goat out of one of these 2. Okay, so you choose door number 1 and he opens door 2 or 3 and reveals a goat. First of all, let's look at this column. Okay, so there's a 1/3 probability that you chose the door with the car. Okay, and that's obvious. That's kind of what we talked about at the very beginning. Now, but let's look at all of the options. Okay, so he reveals that one of these has a goat. Now, if it was this one right here, let's say he opened this door, should you change? We're looking at this outcome right here. Well, of course you shouldn't, because you've chosen the car. Okay? Here's another possibility. He would reveal this door. Should you change? Well, definitely. Definitely, you should change between door 1 to door 2. Now let's look between this outcome. He would reveal this door. Should you change? Well, definitely, you should change from door 1 to door 3. So you can see in the 3 possible outcomes, he always reveals a goat, but out of those 3 possible outcomes, 2 of them would result in you changing. So that means there's a 2/3 probability that you should change. Okay, let's look at it another way. Now, there's this really good math YouTube channel called Numberphile, and I highly recommend that you check them out. There's some really interesting videos in there, and I think in one of their Monty Hall Problem videos, they had what I thought was a really good explanation about this. And in their explanation, they basically they say, okay, imagine instead of just 3 doors, there were 100 doors. Okay, so I'm just gonna make a bunch of shapes. Okay, imagine these door. I'm not gonna do 100 of them, so you don't gotta worry about fast forwarding too much. Okay, so imagine instead of 3 doors, there were 100 doors, and one of them had a car, and the 99 others had a goat. And you chose, let's go a different color. You chose that door. Then after you chose that door, Monty Hall goes and he opens 98 doors and reveals that behind all 98 of the doors that he opens, they're goats. And then he leaves one door open. One door closed. So you choose this door, he opens 98 others, and he leaves this last door closed. Should you change your mind? Well, hopefully you can see here that definitely you should. I mean, I don't know about you, but I would think, well, why did he miss that one? Why did he skip that one? And it's possible that his door was somewhere in the middle. Why did he skip over that one? To me, it almost looks suspicious that he skipped over that one door while he opened up all these other 98. And you can see that the probabilities are concentrated and condensed onto that one door that he chose not to open. So it's definitely a better idea for you to change your mind. Well, there's the Monty Hall problem. I hope this was able to explain it to you a little bit better. Hopefully you understand it more. Thanks for watching. If you like these videos, please like this video. Dislike it or give it a thumb down, I guess, rather, if you didn't like it. And please subscribe if you want to get some more. Thanks for watching.